In this lesson, we are going to talk about the story drift. According to the UBC code, we have three types of drifts. The first one is the story drift, which is the lateral displacement of one level relative to the level above or below. The second type is the story drift ratio, which is the story drift divided by the story height. The last one is the total displacement. And according to the UBC, we need to calculate all of them and compare the result with the allowable values. For the story drift, we need to calculate delta M, which is 0.7 by the reduction factor by the story drift. Then compare the result with 2% of the story height. For the story drift ratio, we need to multiply the story drift ratio by 0.7 and compare the result to the allowable value, which is 1 divided by 360. Also, for the displacement, we need to multiply the story displacement by 0.7 and compare the result to the allowable value, which is the story height divided by 360. And the reason behind multiplying all of them by 0.7 is that the results that come from ETABS are in ultimate state. So, to convert them to the working state, we need to multiply them by 0.7. Now, I am going to do that in ETABS. To display the story drifts in ETABS, we need to define a new load pattern with type seismic drift and assign all the seismic parameters to this load pattern. Also, we need to change its accidental eccentricity if the torsional irregularity exists. So, unlock the model. Then, go to the load pattern. Now, in this form, add a new load with name EX1 drift. Then, change its type to seismic drift. Also, according to UBC 97. Repeat this step again to define EX2 drift, EY1 drift, and EY2 drift. Now, select EX1 drift, then click on Modify Lateral Load Pattern. Now, in this form, enter the previous seismic parameters we have defined before for the EX1 case. Then click OK. Now I am going to do the same for the other load cases. Now, for the EY2 drift, we need to change its accidental eccentricity because torsional irregularity exists in this direction. So, change it as we calculated before. Here, as you can see, I have finished, so I am going to run the analysis. Now, the ETABS has finished the analysis, so to display the story displacement, go to the results, then displacements, then click on the diaphragm center of mass displacements. Now right click on the load case, then choose EX1 drift. Now select the UX column, then right click and choose copy. Then go to the Excel sheet, then right click and choose Paste Special, select text, then click OK. Now enter the story heights for all stories. Also, change the reduction factor to 4.5. Now, as you can see, the Excel has calculated the story drift in each story. Then multiply the story drift by 0.7 and by the reduction factor. And also calculated the allowable value by multiply the story height by 0.02. And if the delta M is less than the allowable value, the result will be safe, otherwise will be unsafe. So in our case, it's safe in EX1 direction. Now I am going to select the EX2 drift. Next, copy the UX column and paste it to the Excel sheet. Here, as you can see, it's safe also in EX2 direction. Now I am going to do the same in the Y direction. So select EY1 drift, then copy the UI column to the Excel. And it's also safe. Now select EY2 drift, then copy the UI column to the Excel. So, as you can see, all stories are safe in the drift. Also, you need to do the same for the wind, but in our model, the earthquake load is the most critical. So I'm going to do these checks only for the earthquake load. Now, click on the drift ratio sheet. Here, as you can see, the Excel has calculated the drift ratio by dividing the story drift by the story height. So it's also safe in all stories in X direction. Also, it's safe in the Y direction. Now, click on the displacement sheet. Here also, the Excel has calculated the cumulative height and it takes the displacement value from the first sheet, then calculate the allowable value by dividing the cumulative height in each story by 360. And our model also safe in the X direction and in the Y direction. Now I have finished all required checked for the equivalent static method. And in the next lesson, we are going to talk about the dynamic method.